Okay, good. Now we're actually going to do. You're going to use three tools that are going to be at our disposal. Now these tools are essential. They're important just because they're going to be required in order to solve these missing lengths and sides. We have to use these three. So write these down because when you go back, look at your notes. We have to be able to understand that you're going to be using Pythagorean theorem, complementary angle theorem, or SOHCAHTOA to actually get our solutions and answers to these different different problems. All right. Hey, listen. Let's go ahead and do now these two helpful and delightful examples. Go ahead and write this down. Write down that we have this example, and also go ahead and please draw the triangle as well. We're going to start by labeling the triangle. There is a correct and an incorrect way to label it. I'm going to demonstrate the correct way. There is some room for interpretation, but it has to follow some consistency. Now draw the diagram as well. Draw the triangle too. All right, excellent. Now, the way we're going to label this triangle is that we're going to call this side A and this side B. These being legs, it's not so important, not so critical as would be the hypotenuse. Hypotenuse, you got to make sure you label that correctly. The bottom of a triangle is normally labeled B, but since the orientation of a triangle could change, it's not critical. What is important is that the angle referring to the opposite of A. Now, opposite means it's directly across in this direction. Just want to show the arrow so y'all see why I mean directly across. You still need to have alpha there. If you switch A and B, which is okay, you got to make sure alpha stays opposite of it. And so does B. B is going to have the angle beta. Now, let's fill in the stuff that we know. We know that A is 4. We also know that alpha is 35 degrees. And we're going to start by finding everything else. The easiest thing to do is that if you're given an angle, then you can use the complementary angle theorem to actually go ahead and actually solve the other angle, which would be minus 90 minus 35 degrees, results of an answer of 55 degrees. So my beta is going to be 55 degrees. That's lovely. But it doesn't, it could help me too. The only thing that's going to be different from what we're doing in the past is that, yes? Oh, you need to go on the outside? Yeah, go ahead. Yeah, go ahead. Oh, no. The thing that is different from some of the other triangles we dealt with is that this one has two unknown sides. I can't use Pythagorean theorem because I have too many unknowns. But I could use SOHCAHTOA to actually achieve finding the sides. You did this normally in geometry. The only thing that you got to get reaccustomed with is you have to feel safe on which trig function to use. I'm going to pick certain trig functions, but once you know the angles and you know one of the sides, there's actually multiple options open to you. There's the opportunity for you to use more than what I'm just writing down. And what I mean is this, I'll use this 35. But if I use 35 degrees, the only thing that's at my disposal to use is going to be the opposite over the hypotenuse. Or I could do also opposite over adjacent. But I'm going to start with finding the hypotenuse. So I'm going to do the sine of 35 degrees and then state that that's going to be the opposite, which will be 4 over the hypotenuse, which is the unknown c. So I'll be left with this equation to solve. I'm going to use algebra the first time to solve for c, but then afterwards I'm going to just tell you the quick way to do it. Algebraically, to isolate c, it will require for us to multiply c on both sides of the equation. And then, so these c's will cancel. And then after that, I need to get rid of the sine 35 degrees, so I will divide that here, and that'll cancel out to 1. But I also need to divide it here on this other side. So the end result is the fact that now I have c isolated with it equaling 4 divided by the sine of 35 degrees. Yes, from there, this is when we use our calculator to actually achieve our answer, a result for the hypotenuse. We're going to find out what this equals. And it's going to equal, now the important thing, and this is something that's not most of the time, but it's often overlooked. And I'll see people giving me answers just because when they opened up their calculator, they gave me they did everything else right, but they gave me a wrong answer because they didn't take the time to look at their mode. This one is in degrees. I'm in the correct setting. It may not always be the case. You might open up your calculator and the mode is radian. It actually defaults to radians. So when you do when you actually go ahead and solve this, just take a little bit of time, be safe, look at the mode, and then from there you'll know what to do next. From here, let's actually do what we have written down there: 4 divided by the sine of 35 degrees, and I'll achieve the answer. Remember, I'm rounded to 2 decimal places, which means I'm going to just write down 6.97. This is really 6.97. Let me box that off. And I'm also going to place that number in my triangle to help me, and if I wanted to use that value to solve. This next one, the next trig function that I'll use, I could have, I'll stick with that 35 degrees. You don't need to. You could actually do any other one. But if I use this 35 again, the same angle, I will have to use, probably the easiest one to use is tangent, because I'm going to leave opposite over adjacent. The adjacent is the unknown side. When you're deciding which trig function to use, it must be, one of the requirements is that whatever it equals to needs to make sure that it contains one of the unknowns. Like in this case, my b is one of the unknowns. One of your equaling parts, or one of the 3 items that goes in there, needs to be the unknown, the variable that you're solving for. Otherwise, it won't work. Yes. Yes. You mean, would you get it? You will get the same, well, you mean as far as what I get, if this is going to equal this? Oh, if I use another angle? Yes, the question is, if I use a different trig function with a different angle, you're going to get the same answer. For example, I have also, you see how I have 55 degrees here? I could go ahead and use, let's see, the tangent of 55 degrees, but I would have to do opposite over adjacent. So it will look slightly different, but I will get the same exact answer. Feel free to do. In your free time, if you want to sit there and play around with it, you're going to see that these trig functions, because the way the unit circle works, it gives you back the same thing. Okay, it gives you back the same values. Let's go ahead and solve this one. Now, this one I'm going to do the quicker way. I'm just going to think about it as like switching the sides. B is equal to 4 over 10 of 35 degrees when it's solved. And from there, to get our actual answer, we can use our calculator. We'll do 4 divided by the tangent. Oh. Well, let me fix that. 4 divided by the tangent of 35 degrees. And I'll get the answer 5.71. So that's what I'm going to write here. 5.71, and also in my diagram over here, 5.71. So I went ahead and it's lovely because I solved all my triangles. Went ahead and did or all the missing measurements. So I guess I'll go ahead and take some time to write that down. And then we'll do another example, slightly different, helpful. That's the delightful part of it, it's helpful. Okay, we'll do this one. So go ahead and write the example as well. And we're going to find the missing measurements. All right, now let's go ahead and solve this one. Same thing is going to apply since our orientation of our triangle is the same. That means that we're going to put the label in. We're going to label exactly the same. A is equal here. B will be here. Alpha and beta will be in the opposite sides, and C will still be the hypotenuse. Now we're going to go ahead and put down the stuff we do know. That's 2, and this is 5. Now this is one of those cases, and we're not given either angle. So we're going to start with Pythagorean theorem to solve for the unknown side. So with this one, let's use Pythagorean theorem. So we're going to do a squared plus b squared is equal to c squared, and then solve for b. You keep it in degree for the most part, unless you're going to plan to express your angles in radians. Always work in degrees. On this case, in solving for b, let's go ahead and subtract 2 squared, subtract 2 squared. Gives me the ability to cancel that out. I'll be left with the result 5 squared minus 2 squared, which is just 25 minus 4. And then you're going to be able to see it, and it's going to become 21. Once we write down 21, we take the square root of it. It's kind of like the grand finale of Pythagorean theorem, taking the square root. And you get that b is the square root of 21. This is lovely, because now I have all 3 sides. What I still don't have is the missing measurement. This is going to require for us to do a technique that you should have practiced this in geometry. But again, the trig function, in this case, having all the sides, you have the option to use whatever trig function you want, and whichever angle you want. And then what I mean is this. I'm going to go ahead and pick, I'm just going to pick one. Let me pick cosine. And I'll pick, let's do alpha. Okay, let me do one. Let's do alpha. Okay, and this is merely, since I have all the sides, I have the ability to use any trig function. I'm going to use cosine alpha. It's going to be adjacent over hypotenuse. The technique will always be the same when you're working with these. Depending on the trig function you pick, it didn't matter which, you're going to use something called the inverse cosine function. So it's the cosine with the little negative on top. So when you look at your calculator, you're going to realize that negative. I haven't used it in a while. It's there. But when you do that on this side, you got to do it on this side. The benefit, the thing that I'm given the ability to do is cross out the cosines because of it. That's what that inverse and the cosine do to each other. And importantly, it isolates the alpha. So I'm left with cosine inverse of the square root of 21 over 5, like this. So go ahead and write this down, because the next step we're going to do is just get the angle. And that's going to be provided from our calculator. Very older techniques of solving. All right. Let's actually go ahead and do the solving process. The function you're going to use above the cosine, you see how it's in blue. So I'll place a blue cosine, and I'm going to go ahead and place down the square root of 21. Let's see, you're going to right arrow over, divided by 5. And that's going to give me my angle 23.6. Now, if you want to have fun with this and see if it all works, you could definitely also use a different trig function. And you'll still get 23.6. Now, you're more than welcome to use another trig function for beta. But actually, the easier thing to do is just use that complementary angle theorem, which means that you're going to take 90 minus 23.6, and we'll get our solution 66.4. And that's exactly what we'll go here, 66.4. And from here, I have all my trick. I have all my measurements that I need for my triangle. What I want us to do is I want you to take the rest of the time and actually work through the assignment. You should be able to do 3/4 of the assignment. The only part that if you have difficulty but it's not challenging is the application part. We'll cover that tomorrow.